I've been on mute the whole time. That's really depressing. Thank you, Lowe's. Um, Here, hang on. I got to give Lowe's some bonus points. I can do it right here. Bonus points, Lowe's. Um, you didn't miss a whole lot. I was rambling about the quiz questions, and then the project coming up next week. We didn't actually get to anything interesting, I think. Yeah, I gave away the answer to the first quiz question. It was false, but you have to correct the statement for everybody who didn't hear me because it's Monday, okay? It's Monday. Yeah, I guess I just shouldn't mute the mic because that was dumb. Okay. Well, moving on then. Exceptions and pointers. Yeah, so the new smart pointers are much nicer. They manage a lot of things for us and help keep you from shooting yourself in the foot. And we'll look at an example of that soon, which is kind of fun. All right, so we start with Visual Studio. Did anybody who's using a Mac, were you able to get everything working in Macland for everything you needed to do? Okay. The unit tests are not going to go well for you, and I forgot to look it up. I apologize. Before Wednesday, I will look this up. Let me leave myself a note here, because otherwise I'll forget. Unit test on Mac. But you can always do it the way the book showed, where you just in main check your inputs and outputs. And it's a little more typing, but it's close. It's just not as pretty. And then there's no like hooking into a continuous integration engine and sad stuff, but that's okay. We'll figure something out. This is just one option here, one tool. All right, so let's start an empty project here. This is going to be, we wanted to do these by topic, right? Not by week number. This will be our exceptions. All right. Make sure it's in my repository folder here so it can get tracked. Check out my GitHub desktop client. I don't want to give any feedback right now. Let's see. There it goes. And nope, that's the wrong class. 200 for fall. There we go. We see new stuff. So I've found the right folder. I put my project in the right spot. GitHub will know about my project. If you don't see these files here, you probably didn't pick the right folder, because it's not too hard to drag and drop, but it's a little like it's an extra step. So if we get in the right place the first time, we don't have to do more work later to make sure it ends up in the right spot. So add new file. This is our source CPP. Sure. And I can close out my test explorer. It's nice. Once you've opened up test explorer, it usually like hangs out here. Wow, that was way zoomed in. See how big that was? Wow. Okay. So you can usually get back to it here when we're actually doing our unit tests in Visual Studio. We can come back here. So our usual stuff, we need to include our IO stream. We're going to be using our namespace, and we'll have an int for main. Oh, I think most people put it on that line. I forget now. It auto formats. The people who fight about where they should go just irritate me, because we have tools now that you click a button or it just automatically happens and will format the code for you. It's not anything we need to spend time discussing whether or not curly braces should go on this line or the next line, because it doesn't matter, right? It doesn't impact our code. All right, so for exceptions, right? This is when we talk about using exceptions. This is the idea that something bad happened in our code, an exceptional thing happened that shouldn't have happened, and we need to deal with it. And generally it causes our program to crash, right? When we start doing funny things and we crash our programs, it's really sad, right? You gotten exceptions before when we crash our program and we're sad? Yeah. For some reason, most of us tend not to be very patient people. And if you're doing something on your computer or you're doing something on your phone and the program locks up and crashes, you just get really frustrated and irritated at it, right? You're like, stupid app. Why is it crashing? It should be better. So we don't want our programs to crash on our users. Even if the user did the dumb thing to make it crash, we should be able to handle that gracefully and tell them, hey, you did a dumb thing, but we're not going to crash on you. Okay, so we need ways of communicating and dealing with those exceptional things that we didn't expect this to have happen. So the first, this is not really going to solve anything here, but we can check for some basic inputs and outputs. So when we were talking about classes and we had our cup class and you could fill it, we had to check if it was negative or positive, or if it was more than the max and these sorts of values. All we did is return a false if it was bad. We'll get to the better way in a minute, but we'll start with just some basic exceptions. So we can ask for some inputs. We'll have an int for, well, how about we have, this will be the length, and I'll have an int for width. And then we'll ask the user, let's enter the length of your rectangle, and then we can see it for length, and similar we'll do for width. Okay, nothing exciting here. And we'll see in for width. Okay, and then we can calculate, how about an int for area is going to be length times width, and then we can see out the area of your rectangle is plus area, and squared units. We didn't ask for units, and that's okay. We'll get whatever units we want here. And if I run my program, we get, okay, what's the length of a rectangle? 3. All right, and what's the width of the rectangle? 4. Okay, 12. That worked great. All right, what's the length of the rectangle? How about -3 and +4? Huh? I mean, the math checks out. It's just no good here, right? You can't have a, yeah, you can't have a negative length. Pretty sure that doesn't work, even in math land. I mean, math is very theoretical, but I don't think you can have a negative length. Okay, so we should check for that. We should make sure they're giving us positive values here. So we can check, we can say, hey, if the length is greater than 0, I'm sorry, less than 0, then we should go do something about it here. And we can force an exception to happen. And again, this is not pretty here. We're just going to start with some basics. We use the throw keyword. We say throw to throw an exception. So exceptions get thrown and exceptions get caught. Right? If I throw something at you, you either catch it or get hit by it. Right? Same idea with exceptions. You either catch it or you get hit by it and your program crashes. Right? Imagine I'm throwing something heavy at you. Right? If it hits you, you crash. Okay? I'm not actually going to throw things at you, although it would be a fun example. I'm tempted sometimes, but it's okay. Right? So we can throw, and then there's a couple different built-in exceptions you can use. Not too particular about them. I think the one is a logic. Logic error is one of my favorite ones. The book likes the runtime error. Sure, I don't. I like logic errors, like something went bad with our logic, and then we can give it a message, and we can say length can't be negative, and we'll throw an error. So now if I give it a negative length, like -3, we get, Visual Studio paused here and says there's an exception that has been unhandled. It wasn't caught. Unhandled exception at some memory address, sure. Standard logic logic error. Okay, sure. I can show the call stack if I want, which is this thing over here. This is what has called what, the stack of, okay, my program is running right here. It's currently at line 16. There's nothing else in the stack really, because that was it, right? But if I have a method or a function that calls something else, and that calls something else, those all get put in this stack here. And we'll see that in just a minute. So you can see what's happening here. And well, there's nothing for me to do. I can just continue. All right, well, sure. Keeps going. We didn't really end here, but it's nice because we're using the debugger, right? If I were to go and run this one, I don't think we actually want to go run it, do we? Just do a debug. Start without debugging. Is that going to work for me? Let's try that. Yeah, there we go. So if I'm not using the debugger, right, I get this ugly little pop-up here, and I can abort, retry, or ignore. I can ignore it, but it does still stop, right? Still ends. And notice there's this exit code that's not 0. Right? Usually we got 0 is like everything's good. Non-zero is usually not good. That sort of thing. So bad stuff happens, right? If we don't want the bad stuff to happen, right, what we have to do is we have to catch the exception. Okay, so in order to attempt to catch it or to try and catch it, we use something called a try block. Right, so I put all of this in a try block, and I can say, hey, let's try something, and a set of curly braces. And let's try, I guess just down to here. It's not super exciting here. After I try, then I need to catch. And when you go to catch an exception, you have to tell C++ what kind of exception you want to catch. So I want to catch a logic error. I think it's just, some people use E, some people use EX, some people spell out exception. It's not too big of a deal here. We're going to say, hey, I want to catch anything that comes up as a logic error. Handle it for me. Let's do something. And I'm going to call it exception here inside my code here. So if an exception happens, the code will stop running wherever it is inside the try block, immediately stops and jumps right to the catch. So any code that comes after this here doesn't run. So if I were to be doing other things with length, right, we could, sure, I mean, maybe we could just see out. You entered a length of length and maybe an end line. So if it's less than 0, we'll get to this throw line. Line 16 never runs. If it's not less than 0, then line 16 will run and the catch is just completely skipped. Okay, is it worth putting in some comments here to note all that? I'm happy to do it. I'm not allergic to comments, I just usually don't. All right, so only runs if the type of exception specified is thrown in the try block. And again, you probably won't have to scroll on your screen. It's just I'm zoomed in a little bit much here. Is that okay? Or I can put it down on the second. I'll put it down on the second line. Why not? Okay. So yeah.
So when you do the throw and catch, is the try necessary? Or?
Yep. Yeah, you can't have a catch without a try. C++ won't let you do it. So you have to, if you have a try, you've got to have the catch. Right? Like as you saw, it got upset when I didn't have that. It's like requires at least one handler. So the message is you have to catch something here. Yep. Hey, happy Blurs Day, Y Paladin. Thanks for dropping on by. So our friend here on Twitch, a fantastic friend in tech. So it's cool to meet people. It was really lonely during the pandemic. So like meeting people on Twitch was really cool. I didn't really go anywhere. Had lots of people at home to play with, but nice to meet people. Okay, so if we catch the logic error, well, we can do something with it. Well, for now, we can just see out. How about there's a exception dot, there's a what method. So exception dot what is going to tell us what the exception is. I like this method. You're like, what is this? Well, you ask it, what? And it tells you what it is. And again, I like end lines, because why not? So if a bad thing happens, we'll catch it here. All right, the length of the rectangle, -3. Length can't be negative. We keep on going, though. The code just, sure, let's keep running. You have a negative length. We told you it can't be negative, but we're just going to ignore that and just keep on running. Not great here, right? Okay. Now, you might be tempted to put this in a loop and say, okay, well, I can just loop here. You sure could. Yep. Now, if this is literally in your main method here, though, using a try catch on your own code is dumb, right? There's no need to use a try catch if it's all your code, because I could just have an if else. I don't need to throw exceptions and have to go catch exceptions. It could just be, if it's less than 0, print length can't be negative. See out it, right? We're just using this as an example here. This is not a good example. We're just using it as an example to show this is a try, this is a catch, this is an exception. Okay. But we could put it in a loop. Sure. Okay, and if you wanted to, why not? So we'll have a Boolean for, how about, let's just do this. So let's set length, and maybe we could just use it off of length. We'll set length to 0, and we'll say while length equals 0. Let's do all of this stuff here. And I'm going to grab all this and throw it in another set of curly braces. So if the length is less than 0, before I throw my error here, I'm going to put length back to 0. Right? So that way, I will throw my error, I will catch, spit out a message, and come back here. Or, you know what, we can even do that in the catch block. It doesn't really matter where we put this. Either way, length will get set back to 0, and then I'll come back up and check my while loop. Is length still 0? Yep. All right, try again. You entered a bad number. Is length still 0? Yep. Try again. Just a loop. Right? Again, we don't need the try catch for this. This is just a little example here, but we can run it. Now we can give it negative numbers. -3, -4. Okay, we screwed something up. It didn't even error at all this time. Wow. Yeah. That's got to go at the top, doesn't it? Inside the loop. We should probably ask him for the value. Yeah. So ask for the value inside the loop. And I'm setting it to 0, make sure it works. You could use the do loop if you like do loops. I don't like do loops. I try my hardest to avoid them because they irritate me. I'm just weird. I don't like them at all. So, and we'll make sure my loop runs once, usually, if I do it right. So the loop will run, it will ask them for the length. Then it should prompt. And again, this is why we are testing our code. We're doing it manually here, but that's probably what you've been doing so far. You run your program, you give it inputs, you see if it does what you expect. Right? We'll get to the unit tests for this stuff later. I promise. We can unit test exceptions. They're fun. All right, -3, -4, -5, -6. It doesn't work, but I give it a positive number, and all of a sudden it works. No big surprise, right? We wrote that code, and it finally did what we expected it to do here. Okay, so we've got our try, we've got our catch. You can validate these things here. What? I think it's confused. Okay, it was just confused. That red line went away. I was confused by that red line too. All right, we can do the same thing for width if we wanted to. I'm not going to bother with that sort of thing. But if you were going to do the exact same thing for width, hopefully a little light bulb goes off in your head and you're like, well, I'm doing the exact same thing twice. This is dumb. I shouldn't type it all out again, right? Anytime you have to do something twice, you should think in your head, hey, what's the better way to do this? I'm lazy. I don't want to have to type it all again. You could cut and paste, yeah, but then you have the same code twice and you should feel bad about yourself, right? They told you that rule of thumb. If you have the same code more than once, you should feel bad about yourself. That's a good rule of thumb, I promise. Just keep that, okay? No, if we're doing the exact same thing and the only thing that's different is a variable, we could turn it into a function. I don't think you need a whole class for it, and we could. And there's like a validation sort of. You could put all sorts of cool validation stuff in a class if we wanted. It might be overkill at this point. I think just a function is probably all we need for now. But I like thinking about classes. I do like that. I am a fan of classes usually. So we can just have a function, right? For like validate number. Does it need to return anything? No, not really. Boy, well, like validate number, given an int for number, and what number is greater than 0, given a number. Can we do that? Is that okay? All right, so let's try it. So if the number is not greater than 0, we can throw an exception. Sure. So if number is less than 0, throw logic error. Number can't be less than 0. That's it, really. That's the whole validate. Sure. Now we validated. Okay, well, I mean, we have other stuff that's happening here so that we didn't put into the method. But we could. So we can, instead of this try block here, we could then say validate. given length. If it throws an exception, we will catch it and continue on. So we haven't really gained a whole lot here. There's still more stuff that we would do the exact same thing for width, right? Okay, so what else is going to be different in our prompts here then? Because I'm not going to ask for the length both times. The other time I should be asking for width. So we probably need to give them some sort of string, right? So let's do that. So let's have another void says ask for number, given a string for the prompt. And this is number greater than 0, or technically equal to 0, which still is not physically possible. We can't really make two-dimensional objects in the real world. Oh my goodness. I need more coffee, friends. Definitely needs more coffee. But it's okay, right? We can fix it if we wanted. So if I give you the string for the prompt, then I can, right? Let's say int number 0, while number is equal to 0. See out the prompt. C in the number, right? And then validate. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund over here at the University of Michigan Dearborn College of Engineering and Computer Science. Got it out in one breath. I have to practice that sometimes. It's a mouthful. So validate the number is greater than 0, given the number. Now, should this have that try catch maybe? Right, inside of here, we might want that try inside of here, right? Because we know that this is where we might have that logic error. And then catch logic error. It's called exception. Take out exception.what, and then we'll reset number back to 0. Okay. So now all we need to do is ask for a number greater than 0. We can't be a void though, right? Because we probably should give them the number. It should be a return type. So let's return the number. When we're all done with all of this here then, right? Once this while loop is done, we can return the number. Right? We know it's a non-zero number, and we know because we're validating it, it's going to be positive. Again, we could just fix the while loop, but that's okay. Right? You just while number is less than or equal to 0, we could just keep on prompting anyway, but this is more fun. Right? So now all of this stuff doesn't need to happen here. Right? I can cut all of that out here. And I don't need to do any of this. So length and equal my ask for a number greater than 0. Please enter the length of your rectangle. Boom, done. Same thing for width. Please enter the width of your rectangle. Look how pretty main is now. Main is like 4 lines of code. We're happy. I'm quite fond of getting main to be essentially just calling your other functions. I think that's a nice way of thinking about what needs to happen. And if we follow this process, this idea of functional decomposition, you heard that term before? Right, we're breaking down a big problem into smaller and smaller and smaller steps. Sorry, you all said yes, but I told you anyway, because why not? Right now, every small problem I have to solve can be a function. I can make functions for all the small things. And again, it's possible to go overkill, and you might not need to do that, but you could. Right? The code's for us. The code's for people. If you like it like that, go for it. Right? If you like one giant ugly main method and it works, you will get the points. I will just make fun of you. Okay? Because you don't want one giant main method. That's not good coding practice. Right? If it gets the job done, fantastic. You can have the points. Right? But you could probably do better. Right? And that's the goal. That's why we practice, is we want to get better. Okay? But now this should work. It should validate. We should be able to get our length. We should be able to get our width. We should try and catch and do all those things. I cut out all the comments. I'm sorry. I realized I did not copy paste them back in here. That's unfortunate. Should we put them back in? Catch the type of error you expect to happen. I think that's what we had in there. I'm trying to remember now. Something like that. Okay. Let's try it. Uh-oh, there's build errors. Validate numbers greater than 0 is not identifier not found. Remember, we have to define these in the right order if we don't have the prototypes. Yeah, you want the one you're calling on top because C++ is dumb, right? It's okay. Or you could add the prototype and say, hey, I've got a method named this. I'll go tell you what it is later. I feel like that's more work. So I will generally just try and put them in the right order here. Okay. Now life should be good. All right, so length of a rectangle, -3. Number can't be less than 0. Please. Okay, some of our couts are a little bit messy, right? We forgot some couts. So let's go fix that. So let's see. Yeah, what? There's an end line. Let's try that again. All right, -3. Oh, we're still at the end of the prompt there. All right, length of your rectangle. So the prompt, and then probably an end line, right? Or at least like a space. I don't know. Do you like being on a separate line? That's what I'm used to. There. So now we get like -3. Number can't be less than 0. Okay, how about 5? Okay, great. We got on the width. How about -2? I hit 3. That's right. Number can't be less than 0. Enter the width. -5. 5. A 5 by 5 has an area of 25. Life is good. We've accomplished stuff. Okay. This was just the start of the practice bit here. So what we could do, and let me go do this here. I'm going to go out to my GitHub here, 200. I'm going to go find our objects and classes here, and we're going to go steal our cup class because I don't want to go modify the other project. I want to have all your exceptions examples here. And I'm going to show you a great example here. This will be our cup.h. And I'm going to put a little note in here from this URL. I've just now cited my source, folks. Right? This is citing your source. Just leave me a comment. I found it here. If it's a Stack Overflow website, paste in the URL. Okay? If it's a page number from your book, well, it's a website too. Right? Everything you're going to cite is a website. If you go out to the library and check out a real physical book, sure, tell me what the book name is and what page number it was, and I'll be really proud of you for checking out a book, which is neat. Oh, I did want to talk about the library. I got an email. So there's a dedicated librarian just for the College of Engineering and Computer Science, and her entire role at the library is to assist the College of Engineering and Computer Science faculty and students with anything research, which is fantastic. And like, she knows what journals to use because she knows like we don't use most of the journals there. There's a couple that are pretty popular in engineering land. That these are the good journals to go find. So she's awesome. She's got like drop-in hours. You can go just walk by her office, and she's usually around. Or you can book appointments, and that service is available at no additional charge. I won't say free because your tuition and tax dollars and stuff have paid her salary, but it's no additional charge to go and meet with her and get some assistance finding research material and that sort of good stuff. So we're not going to do any research for this class because we're just not going that deep. But keep that in your back pocket that you've got a librarian who really loves to see people. She's super friendly and chat about finding good information out there on the internet because the intertubes are rough sometimes, and you can't just go Google stuff. Like academic research doesn't work like Google, which is a little sad. Like I feel like it should be better by now, and it's not. But it's very particular, very particular. So anyway, I'm going to go copy our class here. Well, here's my cup class. Great. So now what we want to do here, I want to stop doing this Boolean thing because I have no guarantee that they're going to care if I return a true or false. Right? If it doesn't really matter, that's fine. I can just return a true or false, and it's up to them to look at it. But like, if they've done something egregious, like really bad, and we should make them fix it or crash, we can throw an exception. Right? You can't give me negative milliliters to drink. That's no good. So instead of just returning a false here, I'm going to make this a void method here. I'm going to throw a logic error. You can't drink negative something. You can't amounts. Sorry, you said something I didn't hear exactly what it was. Logic errors. Milliliters. Okay, milliliters. Why? Okay, there we go. We'll add an include for standard exceptions. It must have done that for me. No, it didn't. I'm confused, but sure, why not? We'll add the include, because go for it. Right? Again, in here, then, we'll throw a logic error. This was going to be, you can't drink more than what's in the cup. In the cup. Where's my end of the quote? There it is. Right? Otherwise, we don't throw anything. Right? We don't need to return a true. We don't need to tell them it was successful. We just don't throw an error. So don't throw an exception. Right? Same idea with the fill cup. We'll make this a void method here, and we will throw logic error. You can't add a negative amount. Sure. We could throw another logic error. You put more in than fit and spilled everywhere. Sure. I mean, these are just strings. We can put anything we want in here, right? It's totally up to us what we're going to put in here. So we're fixing up our class here to force the caller to do something about it or crash. And it's up to whoever uses our class code to deal with that then, right? It just depends what we need to communicate here, what we're trying to show. Okay, so then in my source, then if I wanted to include, maybe in here, right? Is that, I need to, I don't know, include cup H. So if I want to make a cup here, then let's see, let's go back to source, main, we'll make a cup equals cup. And then what do we have to tell cup a couple things, right? We have to tell it the string for the color, I don't know, wood variety. And the max volume, I think, was like 250 milliliters. It had a lid was true. It has a handle was false. Type of material made from was wood. And then current volume, I've got probably 150 milliliters left. And then the contents are coffee, right? Sure, we can make our cup. Cup equals a cup. Then I can go do stuff with it. So if I want to catch those exceptions and not crash, sure, if I don't care, we'll just say cup.drink, let's drink 1,000 milliliters, and we can crash. Now this stack trace is slightly more interesting. This is what I wanted to show you. So we started at our exceptions, and I'm sorry I can't zoom this in, the exceptions class main method line 41. So source CPP main method line 40. Okay, the line number's off. I don't know why it's bad at that sometimes. That still confuses me, but sure. Really, it was line 39. Should be better than that, but okay. Then from line 39 here, we called the drink method. So we're in the cup class drink method now. So the drink method was called. So in that call stack, remember when drink is done running, C++ has to remember where to go back. That's probably what it is. It's going to go back to line 41. Maybe that's what it is. We'll pretend like that's what's going to happen because that's the next line to run after this. Right? The next line will be 41. So once drink is done, we'll go back and run line 41. But an exception happened. We didn't handle it. We're crashing. So oops, no good. And we'll stop that. So if we're using a class that can throw exceptions, we can add in the try catch. Right? So we can try, and then a similar idea here, instead of like just cup drink something here, how about we have a cout for much do you want to drink? Want to drink in milliliters. Wow, that was the wrong. To drink in milliliters. And then we can see in milliliters. Probably need to tell it we have an int for milliliters first. Milliliters? There are two L's? One L? Two L seems right. Right, and then we can drink the number of milliliters. So I have no idea what the user is going to enter here. It could be a valid amount. I could try and drink 50 milliliters, or I could try and drink 1,000 milliliters. I don't recommend you try and drink 1,000 milliliters. If you're not familiar with the metric system, that's a liter. Right? Try and drink a liter at once. It's probably going to go bad for you. I mean, maybe you can do it, but again, sometimes the metric system confuses people. So So we've got to try, and now it's a red here. We need at least one handler. We need to tell it how do we want to handle this exception. Right, so we can catch. We're going to catch a logic error here, exception, and we'll just see out the exception dot what. Not the greatest thing in the world here to just spit out the exception, but for now, sure, that that's okay. We don't need to put them back in a loop, and with this sort of example, if I didn't have access to the cup class, like imagine this was a class in a library that I don't have the source code for, right? The only thing I can do is basically go back and try again. I can't go change the code to make it not throw an exception. And this is what we're kind of building towards. As we write classes, we make code that's useful and reusable is sort of the goal here, because our code's going to be amazing, it's going to be reused, and it's going to exist for a long time. People are going to have to modify it. You move on to bigger and better things, and then new people will come in and have to maintain your code. And that's why you want your code to look nice and to be formatted nicely and to be easy to read, because it's not going to be your job forever to maintain that code. Like, you don't want your job to be forever to maintain your code. You want to move on to bigger and better things, right? You guys have big plans with your lives. Don't be stuck maintaining your cup class, right? Let the next poor sap who's a new hire go do it, right? So make your code readable so it's easy for them to do that. All right, so we'll just catch, and let's see if we can catch our error here. So how much do we want to drink in milliliters? If we say 2,000, you can't drink more than what's in the cup. And we just keep on going because we didn't bother with the loop here or anything. Right? And we could do all sorts of fun things. We could have a while loop, like as long as the cup isn't empty, right? Because we have these ways of getting the current volume. Say, as long as the volume's not zero, how much do you want to drink? And we'll make someone sit there and drink and drink and drink and drink until it's empty. Sure, we could do that. Right? It's whatever we want to do with our code. But this is us using some exceptions here. Okay. The other fun thing you can do with exceptions, and I'm not all that fond of it, although I guess it's a fun exercise, is you can make your own exceptions. So it doesn't have to be a logic error. It can be a Eric's custom exception error if you want. We'll get to that later because we haven't really talked about inheritance. Where I can read this one here. Once we start talking more about inheritance, that'll make a whole lot more sense, making your own custom exceptions. Okay, we'll come back to it. And again, I'm not even really convinced custom exceptions are all that useful, but they're fun. They're fun sometimes. Okay, this is new, right? Exceptions was new? No? You let me talk this long about something that wasn't new? Friends. Oh, now I'm feeling bad. Okay. Wow, that was depressing. Okay, we could have just moved on. It's Monday. We wanted just an easy day. Review day is good. All right. Did you put exceptions in classes before? Yeah?
It was new to me.
Okay, all right. So valuable for at least one person. You're making me feel better about myself. Thank you. I want to be useful. Like, I don't want you to be bored. Don't show up if you're bored. That's no fun. So, all right. Well, thank you. Thank you for making me feel better. Let's talk a little bit about pointers. We don't have a ton of time to talk about pointers, but we'll get into a couple things here about pointers. Now, they're not new, right? We've heard of pointers before. Okay, unless you transferred in and hadn't had C++ before, which is the case for some people. So it'll be new for some people. All right, so this is going to be our exceptions project. So let me go ahead. I've got this all saved. I'll commit this here. Here's exceptions, commit and push. And I'll start up a new project. Oh my goodness. Come on, mouse. Start a project for pointers. Make my project. In my repository folder, GitHub should see some stuff. Look, hey, there's a pointer solution file. Great, life is good. Grab a new source file. Source CPP. I should have. All right. I don't want to have to retype everything here. Nope, got too much. There, we'll just do this. There. No, I don't have to type the rest of that. Is our line? Is our curly brace usually there? I'm not sure. I think we can automatically format it. Format document. Format document is one of your favorite tools here. It will format it based on whatever standard has been set. Visual Studio has some nice stuff too, where you can include a file that tells it, I want to format things a certain way. It's really fantastic. Got a lot of nice shortcuts. All right, so using pointers. Remember, a pointer, its job is to point to something else. I hate pointers. They're annoying, but that's okay. And so when we have a pointer to something, it's a variable that stores what? It stores the address in memory of the thing it's pointed at, right? So all it does, the value of a pointer is a memory address. That's the big sticking point here. So I can have an int for a number is 42, and I can have an int star, an int pointer to another number. With a pointer here, I'm pointing at a memory address. Now, with integers, it's a little silly, but that's okay. Not too big of a deal here. Oh, we got a question about exceptions. What advantages do writing exceptions have over testing input and counting an error message? That's a good question. So yes, I did not talk enough about that. So the exceptions project. When you write your own custom class here, like cup, you have no idea where cup is going to be used. It's not up to you. You wrote a class, someone else is going to use it. They could use it in a desktop application run at the console. Sure, people will see cout messages. If they use it in a web application, they're not going to see cout messages. If they use it in a mobile application, they're not going to see cout applications. If they use it in a graphical user interface program, something with like buttons you can click on, they're not going to see cout messages. A class should not ever see in, cout anything, basically ever, unless it's only designed to work at the console. And when we talk about good design, well, that's not very flexible and reusable if it only works at the console. Pretty much every class we ever write will only deal with arguments and returning values. You give the class something, it does some work, it gives you back a value. Right? The class's job is not to communicate with the user. Right? The source file that has a main method, that's job is to communicate with the user using cin and cout. Right? Or your graphical user interface's job with buttons and widgets and things to click on and drop downs and type text boxes and all that stuff is to communicate with the user. Or your web application's job is to communicate with the user, give them forms to put data in. Or your mobile application, right? That's where the user interaction happens, not your class code. So cin and cout in a class is really bad, really ugly, bad form, right? I see it a lot and I make fun of people all the time. It works for what we're doing, but it only works for what we're doing because we're writing these terrible console-based applications that the majority of people don't use console-based applications anymore. Some people still do, and they're still have value and have purpose, and there's lots of things you can do with console-based applications, but the majority of users have no idea what the console is. Imagine your Unix lab, but you tell someone to run your program and type stuff into the console. Like, hey, go and open up the Windows terminal or your command prompt and go to my directory and run my executable. And their eyes are going to roll back in their head, and they're going to give up. Right? Well, what are you talking about? This is stupid. Right? They're not going to do it. So cin and cout in our classes is bad. Thank you for that question. All right, so our pointers here then, right? Another number equals 100. I get value of type int cannot be assigned to entity of type int pointer. When we use pointers, we have to deal with them as pointers, right? So we have two options. We can dereference the pointer, right? And say, hey, I want the thing that this references, right? That's dereferencing. It's getting that reference and say, okay, put it here, right? So I can't store 100 directly at this memory address. Because remember, a pointer is a memory address. So what this is storing is not an integer value. You don't want to put an integer value for this value. You don't want to give it that because then it won't point to somewhere in memory. You just gave it. And integer values can be memory addresses essentially. They happen to be hexadecimal because reasons. Go take the 310 class. They talk more about that. So we don't want to do that. But what we could do is we could say, hey, I want it to equal and we assign it the value of number here. And I don't want number, I want the reference to number. Enter all sorts of crazy symbols. So the ampersand sign is the address of something. So instead of dereferencing it, we're saying, hey, go assign yourself a value of the address of number. Right? Assign the memory address of number to another number pointer. Right? So now if we were to see out another number, what are we going to get? Are we going to get 42? No. Right? What's the value of another number?
The address.
The address. Yep. Pointers are weird. So this is the memory address where 42 is being stored. This is not useful for people. Right? No one cares what this value is here. So if we want to get the value stored here, now we need to do the dereferencing. So to get values out, we have to dereference them. And that's our star notation. And a lot of times people put that in parentheses. I don't remember why. I think it's more useful later so we can do like dot notation stuff. You'll see it a lot in parentheses, right? So the star then, this gets the value referenced by the pointer. Uh-oh. Am I offline somewhere? Okay, it's just a blip. I think we're back. So now I can get the value stored by another number, which is 42. Okay? Now if I say number equals 100, and I see out another number, what are we going to get? 100. Right? Because we changed the value stored wherever number was being stored. When we just say int number, number technically is a memory address. The variable is a memory address. It points at some integer in memory somewhere, but we don't have to deal with, hey, I want your memory address or I want the value. The compiler just knows we're always talking about the value, because why would we have to deal with memory addresses? That's crazy. Right? This is a lot of extra work, but we'll get to some why it's cool in a little bit. Right? So what I have here now, I have two variables pointed to the same location in memory. Right? This is a technical term for it's like a shallow copy. It's not an actual copy of number. Right? It's just looking at the same place. They're both looking at number, wherever that variable is in memory. Okay? If I wanted to change the value of another number, right? I can dereference another number and say, hey, let's equal 7. And again, I think it's relatively common to do these parentheses here. I think usually you'll see it that way. And it's just another like visual clue, like we're doing something. So we can set it to 7, and then we can see out number and line. And we get 7, right? If they're both pointed to the same location in memory, if I change the value referenced by another number, I've changed number, because number is stored at this place in memory. That's our basic pointer, right? Stores an address. Now, it's not super useful for these basic types here. Not the most useful thing in the world, but you can do some funny things with pointers, okay? You probably covered this, so I won't spend too much time on it here, but we can write some fun functions here. Okay, so let's write a function like, let's make it a void method here. This is our quadratic solver, given an int for a, an int for b, and an int for c. Right, remember your quadratics? X equals negative b plus or minus the square root of b squared minus 4ac, both divided by 2a. That really should not be in my head, but it's been in my head since 8th grade, and I can't get it out of my head. Like anytime someone mentions it, like it pops back into my head, and I need to remember other things. I don't need to remember this equation that I can Google. I can't get it out of my head. It drives me nuts. Oh, Melhadi, how do we know what type the error of the exception is? So generally, libraries will tell you what exceptions they throw. We knew it was a logic error because we wrote it. or if it crashes, you see what the exception type is. That's a good reason for adding comments and documentation, so you know what types of exceptions are thrown. But yeah, usually it's in the documentation somewhere, or it crashes and you notice it. So the problem with functions is you can only return what? One thing, right? Our quadratic solver here, because x is plus or minus, or plus and minus, that's two values, right? I can't have int x-intercept 1 and int x-intercept 2. I can't return x-intercept 1, x-intercept 2, because this isn't Python. Python lets you do this, and it's amazing. Python's such a better language. I'm not biased at all. You can't do this here. Well, how do we return some values here? Well, we can do some crazy things like, hey, I want an int address for x-intercept 1 and an int address for x-intercept 2. Okay, now I don't need to return values. I can set them right here. I have access to the address. I don't need to redefine those here. I can say x-intercept 1 equals 10 or something, and it will store 10 in the address that was passed. And if you have a variable with an address, right, so we can come up with, so we can have an int for a, b, c, x-intercept 1, x-intercept 2. I generally don't like doing this, but I was feeling a little lazy. So I define them all in one line. It's ugly, but sure, why not? Then we can see out. Please enter your a value and we can see in for a, and on and on and on, right? A, B, C, B, C, B value for B, B value for C. Okay, then we can call our quadratic solver. Our quadratic solver, we can give it A, B, B, C, the x-intercept 1, x-intercept 2. Oh, no, oh my goodness, I want the semicolon. Right, we can pass it our values, and then we can see out your intercepts are x-intercept 1 and x-intercept 2, and that line. We can pass it these values that can then be set inside the function without having to return something, because we gave it the address of our variables here, right? So let's try it here. So we get the double for the determinant, I don't remember, right? That is negative b, I'm sorry, no, the square root of b squared minus 4ac, right? Or b times b, b squared minus 4 times a times c. And we're going to need to use the square root of that. I forget if you have to square it first or not, right? And then if the determinant is negative, we're not going to have any intercepts, right? Because you can't take the square root of a negative number. Yeah, so we could give some sort of message, or hey, we can throw a logic error. Why not? Because we, throw logic error. No x-intercepts exist. And again, maybe not a logic error is the right thing to do here, but that's okay. Why not? We'll have some fun with it, right? Okay. Otherwise, then we'll get the x-intercept 1 is equal to negative b plus the square root. Is it math? Oh my goodness. Is it built in? Square root? Yes, built in. Fantastic. The square root of the determinant. That whole thing, right? Oh my goodness. Come on, parentheses. Divided by 2 times a with more parentheses, right? Order of operations will get you here, right? Divided by 2 multiplied by a is not the same as divided by 2a, right? I appreciate that you folks understand order of operations. This is not always the case, and that drives me nuts. And then I'm sad about our own, elementary, middle school education. Like that's not even a high school thing to learn order of operations, right? And then we'll do minus. And these could be the same number, right? There might just be one, and that's okay. Right? We'll set them both, whatever happens to be. Fantastic. Now, if a is 0, we've done a bad thing. We've divided by 0. Probably we should check for that at some point, right? If a is 0, you're not a quadratic. Yeah. I love the math, people who know math, because it's not my strong suit. It used to be, but it's gotten harder. Maybe we could check for that as well, right? Why not? Let's do that first. So if a is equal to 0, we'll throw a logic error. That's not a quadratic function. Yeah, sure, function. Thank you. Why not? Let's try that. Give it a run. All right, so what's our value for a? Enter your a value. Oh, it's not very clear that I was looking for a. Your a value. That's okay. 3? Sure. What's our b value? 23. And what's our c value? 47. Uh-oh. Something bad happened. Logic error at memory location. We got a logic error. It was too big? Yeah, the determinant is negative. Yeah. So, yeah, logic error, determinant was negative. That was us. Right? We entered bad values. Sure. So maybe we should try and catch this then, right? Try and catch a logic error. Call the exception. And see out the exception what? Right, now it shouldn't crash here. All right, let's try some other values. 2, 4, 6. No x-intercepts exist. The intercepts are, oh, those are bad default values. Oops. Maybe we only do that if we don't catch. And look, we can put that inside the try block. If this raises the exception, this line never runs. Right? This is the other cool thing with try blocks. As soon as an exception happens, it stops, jumps right to the catch. So this line won't run if the exception happens. All right, how about something that has a solution, right? We just need like a big negative C, right? Like 2, 3, and like negative 10 or something, or more. I forget, negative 20. There we go. We get 2 and negative 4. Does that check out? We should graph it. So 2x squared plus 3x minus 20. Is that Desmos? Is that what you guys usually use? Desmos is fantastic. We want, I forgot the numbers already. 2x squared, 4x minus 20, 3x. There we go. Those look better. Negative 4, 2.5. Huh. Oh, well, what do we do with our x-intercepts? I said they were integers. We stored an integer. We sure did. We should probably make those things doubles, right? This is why me being lazy was bad, friends. Not always a good thing. So then these should be doubles here, right? Doubles. Now let's try it. So we had 2, 3, and negative 20, 2.5, and 4. Right? And Desmos checks us out. Negative 4, 2.5. Life is good. Okay. So using pointers, we never really said this was a pointer. We just said, give me the address of something. Because essentially your variable really kind of is a pointer. We're just not being explicit about it. You can do silly things like this. So that way you can not return more than one value, but set more than one value. Right? We're giving it access to our memory address. We say, hey, this is where you can go put a double value in, and I'm going to keep looking at that when this function's done. Right? So what happens behind the scenes? We tell C++ we want 2 doubles. It allocates 2 locations in memory. Here's double number 1, x-intercept 1. Here's x-intercept 2. They take up however many bytes of memory a double takes up. Is it 8, 16? I forget off the top of my head. We could Google it. Right? we know what those memory addresses are because we have the variables for them. When I go use the function, we say, okay, here's the memory address. Go for it. Go put a value in memory at this location. I can go read it out now because I have x-intercept 1 and x-intercept 2. Right? We can do that. You okay so far? Was this new? No. Okay. All right, we're about out of time here, so let's pick up more with pointers, hopefully new stuff then on Wednesday. Sorry if this is a big review day. And then we'll go from there, okay? All right, thanks, folks. I'll put this to GitHub too. First review. Take care, everybody online.